Why do you land on the ground when you jump up instead of floating off into space? Why do things fall down when you throw them or drop them? The answer is gravity is the invisible force by which a planet or other body draws objects toward its center. The force of gravity keeps all of the planets in orbit around the Sun. Albert Einstein described gravity as a curve in space that wraps around an object, such as a star or a planet. If another object is nearby, it is pulled into the curve that is created by the larger body due to its significantly larger weight. To further understand gravity, we need to also understand mass and matter. Mass is a measure of the amount of matter in an object. Mass is usually measured in grams or kilograms. Matter is everything around us. Atoms and compounds are built up from small parts of matter, essentially the building block of anything and everything. Anything that has mass also has gravity. Objects with more mass have a higher gravitational pull. Over a large distance, gravity begins to weaken, so the closer objects are to each other, the stronger their gravitational pull is. Earth's gravity comes from its mass. All of its mass makes a combined gravitational pull on all of the mass in your body. That's what gives you weight. And if you were on a planet with less mass than Earth, you would weigh less than you do here. To put things into perspective, an object that weighs 45 kilograms or 100 pounds on Earth will only weigh 7.7 kilograms or 17 pounds on the Moon, and 17 kilograms or 37 pounds on Mars. Gravity does not only pull on mass, but also on light. The effect is called gravitational lensing. When light rays pass through massive objects in the universe, the gravitational pull from these objects will distort and bend the light, causing it to no longer travel in straight lines. Gravity is not the same everywhere on Earth. It is slightly stronger over places with more mass underground than over places with less mass. NASA uses two spacecrafts to measure these variations in Earth's gravity. These spacecrafts are a part of the Gravity Recovery and Climate Experiment mission. GRACE detects tiny changes in gravity over time. These changes have revealed important details about our planet. For example, GRACE monitors changes in sea level and can detect changes in the Earth's crust brought on by earthquakes. An interesting fact about gravity is that it is the weakest force that we have discovered, despite its gargantuan job of holding planets and solar systems together. But on the flip side, humans and animals can very easily overcome gravity by jumping or throwing objects. The reason this force can be so strong yet so weak is because it relies on the mass of the objects it is surrounding. Scientists have been researching further into gravity and how exactly it is carried through the universe. In the standard model, particles interact with each other via other force-carrying particles. For example, the photon is the carrier of the electromagnetic force. The hypothetical particles for quantum gravity are gravitons, and scientists have some ideas of how they should work from general relativity. Like photons, gravitons are likely massless. If they had mass, experiments should have been able to visually spot these particles. But it still doesn't rule out ridiculously tiny mass that may not even be visible to us or our instruments. Has your curiosity been fulfilled? If so, leave a comment down below, and if you're curious about more, then check out our social media for daily facts. Also, don't forget to subscribe for more educational content and hit that bell icon to stay up to date with future uploads.